Hello everyone, welcome back to JDCodebase. In this video, we are solving LeetCode 45 Jump Game Part 2. I want to say one thing before we start. If you did not understand this problem earlier, that's normal. This problem is not about jumping, it's about the counting ranges. Let's slowly see what that means. So, in the problem statement, you are standing at index 0. Each number tells you how far you can jump from there, and your goal is to reach the last index and using the minimum number of jump, and that's it. This is the only problem statement. Now let's take this example. Nums array 2 3 1 1 4. From the index 0 the value is 2, so I can jump to index 1 or index 2. But instead of jumping immediately, I will ask a better question. How far can I reach if I use one jump? From index 0, the answer is index 2. So let's first talk about the brute force solution. Brute force means I will try everything and choose the best one. From index 0, try jumping to index 1, try jumping to index 2. From each of those, try again, and eventually I reach the end and count the jumps. This works, but it is very slow because the same work is repeated many times. And I will not go deep into the brute force code here. Just remember this, it uses the recursion. It tries all the jump and it returns the minimum. It is correct, but not the practical for the interview solution. So now let's see the optimal solution. Optimal solution is the turning point for this problem. Here is the main idea. We do not need to decide where to jump. We only need to decide when a jump is required. This changes everything. Now let's think about the range from index 0. Let's see the example. At index 0, value is 2 here, and so with one jump I can reach the index 1 or index 2. But this is my first range. I do not jump yet. I just walk inside this range and look here. So walk inside this range means 1 or 2. Inside index, now I check index 1 at this index at 3. Index 1 has the value 3. So from here I could reach index 4 easily, means 1, 2, 3. I could reach index 4. That means with 2 jumps I can reach index 4 easily. But I remember this. I still don't jump here. Now I reach at index 2 at this position at 1, and index 2 is the end of my current range because for index 2 for this 2 range is the only this 3 and 1 only. So index 2 is the end of my current range. I have no choice. If I want to go further, I must have to jump. So now jump count becomes 1 and new range becomes 3 or 4. Now I walk inside the new range. As soon as I reach the end again, I take the second jump. I reach the index the 4 and game over. Total jumps is the 2, means from this 2 to 3 and this 3 to 4. Now let's write the code for this. So for this let's first initialize the 3 variables. Total jumps is equal to 0. Let current end equal to 0. Let farthest point is the 0. So here jumps count how many ranges we finish, means my final answer, and the current end tells where the current range ends. Like here for 2, the current range is the 3 and 1 only. So at 1, when I reach at 1, my current range is the about to end. And farthest tell how far the next range can go, means I am standing at index at this 2 and I am seeing how farthest can I go, means till this 1. At index 1 I am at this 3. How farthest I can go at till this 4. So this is 10. So now let's start a for loop for let I equal to 0, I is smaller than nums dot length I plus plus. Now I walk through the array, but I stop where the last index, before the last index. So for that, nums dot length -1, and get the farthest is equal to math dot max farthest I plus nums of I. So at each index, I ask if I jump later, how far can I reach? Means I just get at index 2, how far can I go till this one? At index 3 means at index 1 at this 3, how far can I can go? So if I for that I get this farthest point. Now check if I equal to current end or not. So this means I finish the current range. Means at if at the index 1 at the index 2 I reach the 1, and my farthest point is this again 1. So I have to jump this jump plus plus. I have to take the jump. I have no other option, and update the current and also with the farthest point. So I take jump and extend the range. Now return the jump in last from this jump function and run this, and let's submit this. Yes, it runs. And why this work? Because each jump cover the largest possible range, and so the number of jumps is always the minimum one. So let's compare the solution, and time complexity for this is big of 1, and space complexity is the big of 1. Time complexity is the big of n because only one for loop, and space complexity is the big of 1. And let's final comparison is the brute force try all the paths and recursively, but greedy count ranges. So if this problem confused you earlier, that's normal. What matter is now you understand it or not. And once you understand this, many greedy problems becomes easier. Thanks for watching. I'll see you in the next video. If you like this videos, like the video, subscribe to JDCodebase and comment your doubt if you have any.